Welcome. We are from Faculty of Engineering, University of Brunei, proudly presenting our final year project, Synchronverter for integrated renewable energy into the power grid. So let us move on to the pipeline. So as we know, there are lots of distributed energy resources over the world. As they exist, the main purpose is to extract maximum power from the source and inject it all into the power grid. So 22% of renewable energy share is increasing, so we need storage units are required to mitigate the random fluctuation and store the energy that we need. Then the main challenge is to controlling the inverters in this distributed power generators, as we implementing more inverters when we are integrating renewable energy into the grid, so we are facing lots of fluctuation. For mitigate those fluctuations, we are introducing Synchronverter, improvised Synchronverter as the solution. So this is how it works. This is the graphical representation of all connects, and we implemented two modes, software environment and the physical environment. So in the software environment, we have analyzed three case studies: the performance of synchronous generator with load, which actually loads with the grid, and we have analyzed performance of synchronverter with load, so our solution with the load. And third one is we have analyzed performance of synchronous generator, synchronverter with load variation. So this is the software prototype that we have created with MATLAB simulation. So it is in here we have analyzed synchronverter, synchronous generator, and load. And this is the control model of the prototype that we have developed with the model that we have represented earlier. As you can see, this is the physical prototype that we have developed. So you can see the DC power supply. And moving on, you can see the synchronverter physical setup, which includes the controller mechanism, which includes the microcontroller, and of course the inverter. Then you can see with this that Synchronverter, the output control signal will be fed to LC filter. So the inverted voltage waveform will be smoothened by the LC filter and go to the transformer and connected to the load. So this is the whole prototype that we have simulated around the pipeline. So here we have two output waveforms. First one is the Synchronverter connected with load, so it shows the sinusoidal waveform, and of course the right side we have the output waveform with Synchronverter connected with transformer, which shows the sinusoidal waveform. So Synchronverter actually mimics the action of synchronous generator. So for the synchronous generator connected with load and the grid, there should be like a sinusoidal waveform. Of course here you can see that behavior is representing in the physical prototype. So furthermore, we are saying why we telling this Synchronverter effectively mimicking the action of synchronous generator. The first one is the frequency response load changes. So when there's a change in load, synchronous generator will show a transient change frequency before it stabilizes. So it evidence that Synchronverter is doing the same. And the second one is the voltage and current waveform analysis. So as we have seen in the sinusoidal voltage waveforms, so it shows and it's able to mimic that behavior. And the third one is active and reactive power control. So synchronous generator can adjust its output power and power factor by varying its rotor excitation, torque. So the Synchronverter should be able to do the same and able to do that. And the fourth one is harmonic content. So over the physical analysis, we have seen the total harmonic distortion with the voltage and with the current set below 5%. So we have able to do that with our Synchronverter solution. So the synchronous generator inherently produce a minimum harmonic distortion. So with our Synchronverter solution, it able to reduce the harmonic content to a minimum extent. So this is how that we have proven that our Synchronverter, a novel solution, is able to make the action of synchronous generator and able to reduce the fluctuations. This is our team. So I am the narrator, Vijayagon WMKGVB, and Professor WMDU and Piravian. Thank you for listening us out.